Hello everyone, welcome back to my channel. Today we'll be solving the Leetcode daily problem, minimum number of arrows to burst balloons. So this question is today's Leetcode daily problem. If you solve this, you can get 10 Leetcode coins. So I'll not be reading the question, I'll just explain the test case, and while explaining the test case, I'll explain the problem. The problem link will be in the description, you can go and check that out. So in the problem, we are given a 2D vector. We're given a 2D vector which has a number of balloons. Like here we are given a vector, 2D vector, which contains 4 balloons, and in the vector we are given two set of points. So the two set of points indicate the start of the balloon and the end of the balloon. So we are basically given the diameter of the balloon, right? So here the first balloon, 10 is the starting and 16 is the end. Here in the second balloon, 2 and 8, 1 and 6 for the third, 7 and 12 for the fourth. And we have to find the minimum number of arrows that must be shot, that is either from the up or from the down. We can shoot from both, anywhere from the y-axis, and we have to burst all the balloons, and also we have to return the minimum number. So let's see the first test case. So here is the first test case. I have drawn the points on a infinite 2D plane, and this depicts the balloons, okay, the balloon's diameter. And now we have to shoot arrows from either from here or from here, any from the top or from the bottom. We can shoot arrows and we have to burst the balloons. Now how to make the number of arrows minimum, right? How to make it? See, the first balloon from here till here, and the second balloon is from here till here. So if we can select such a point that has as many number of balloons, that has a connection with as many number of balloons as possible. Suppose this point 4 has a connection of first balloon as well as the second balloon. If we shoot from here, from the fourth point, it will burst the first balloon and this balloon also. Both the balloons will be burst. Okay. But see, we can't select any point that has all these 3 balloons. We can't select because here is some space, and so we can't select 3 balloons, any point that can burst 3 number of balloons. So these 2 balloons can be burst from here, from the fourth point. Now let's see these 2 balloons. These 2 balloons can be burst anywhere from here, this point, because this is the common of these 2 balloons. Similarly, here also, this part is the common of this balloon, and this part is the common of this balloon. This part is the common of both the balloons. So from anywhere from here, if we shoot an arrow, it will burst both these balloons, and anywhere from here, if we shoot an arrow, it will burst these balloons. So the at most minimum that we can go in this test case is 2, and we will see the answer is 2. The answer is 2. Here is the second test case. Here is the first balloon, second balloon, third balloon, fourth balloon. Now here is an interesting case. We see no balloon is having a common point or a common area with another balloon. So here what we can do, we can shoot anywhere from here to burst the first balloon between 1 and 2, to burst the second balloon from here, third balloon from here, fourth balloon from here. Alright, so we have to shoot 4 arrows because all the 4 balloons has some amount of space in between them, all the 4. So there is no common connection in between them. So the least that we have to shoot here is 4. And see, the answer is also 4. So let's now take a test case which will cover all the conditions, all the edge cases. So 1, 2, 3, 4, 5, 6, 7. We have 7 balloons here and the coordinates are marked. Okay. So here is the first, suppose, second, third, fourth, fifth, sixth, seventh. So what is the most optimal way that you can think of? We can start from 0, we can start from the origin, and we can go on traversing in this direction, and if we find a point that is common to the first balloon and we keep it in a variable, we find the point that is common to the first balloon. Fine. Okay. So what are the points that are common to the first balloon? This is our first balloon according to ascending order. So we see that 1 and 6 are the points that are common to the first balloon. So we make here 1 and 6. Okay, so that is, if we shoot anywhere from here, we'll burst that balloon. Let's go to the next balloon. Next balloon, the points are 2 and 4. So think, if we shoot between 1 and 2, can we shoot both the balloons? No. We have to find the maximum of the starting point, that is 2. If we shoot anywhere from 2, we can burst both the balloons. So now we'll take, instead of 1, we'll take here 2. And see, can we shoot anywhere here? If we shoot anywhere here from 4 to 6, we won't be able to burst both the balloons. So to burst both these balloons, we have to find the minimum of the end part of the balloon. So it was 6 and 4, the minimum is 4. So we take 4. That is, in between 2 and 4, if we shoot anywhere between 2 and 4, we can burst both the balloons. Okay, fine. So next, now go to the next balloon. That is from 3 to 5. Again, we have to check that is the maximum of the start. So 2 and 3, we can't shoot a arrow here. If we shoot, we won't be able to burst this balloon. So we have to shoot from 3. So let's make here 3. That is the maximum of the start. So 2 and 3, which is maximum? 3. So we shoot from here. And the minimum of the end, that is 5 or 4. See, the second balloon does not have anything here. So we can't shoot here. If we shoot here, we can burst the third balloon and also the first. But we can't burst the second balloon. So we have to see the minimum between 4 and 5. Which is the minimum? 4. So we have to shoot anywhere between 3 and 4. Then only we can burst these 3 balloons. Okay, now the fourth balloon. The fourth balloon starts from 4, ends at 8. Again, our algorithm, maximum of start. So 3 and 4, which is the max? 4. So you have to shoot anywhere from 4. See, if we shoot anywhere from 4, we can burst all the 4 balloons, all the 4 balloons, all the 4 balloons. And the minimum of the end. So 4 and 8, 4 will be the minimum. So 4. If we shoot at 4, we can burst all the 4 balloons. So our arrow count will be 1. Okay, but we won't. Here is our arrow count. We won't be updating it now. Next, what you see, so our coordinates was 4 and 4. Next balloon has a coordinate of 7 to 10. Now, if the starting coordinate of the next balloon is more than the ending coordinate of what we are checking, that means there is a space in between. That means there is a space, right? That means there is a space in between. The space might not be of this balloon and this, but we are shooting an arrow. The space between where we are shooting the arrow, because we are shooting this arrow so that all the balloons are destroyed, not this, all the balloons. So you have to find the common. The common is at 4. So from 4 and 7, we have a space. We have a space. So this arrow can't be used to burst this balloon anymore. So when we can't do it, we have to increase the array by 1. Array is now 1. The arrows, number of arrows. After this, what we have to do, we have to update our common variable that we are keeping. Okay, we have to update it to the new set of points. New set of points is what? 7 and 10, because we have to select another arrow. Now this becomes for the second arrow. Okay, this becomes for the second arrow. The new variable that we will be keeping becomes for the second arrow. So it will be 7 and 10. Now check the next balloon. Simple. What we have to do, the max of the start and min of the end. So the max is 9. 9 and 7. Max is 9. So we have to update this to 9. Because see, if we fire an arrow from 9, we can take both the balloons, right? And the minimum of 12 and 10. What it will be? 10. So if we shoot an arrow between 9 and 10, it will burst both the balloons. Again, when we go to the next balloon, that is here, we see again there is a space between the end of our variable that we are keeping and the start. So what we'll do, we'll increase array to 2 and we'll update our variable. So now the variable will be 13 and 14. As there are no more balloons, so we have to shoot one arrow at the last to burst this balloon. So our answer will be 3. So I hope you have got the intuition and the basic approach to solve this problem. So we'll be going now to our Leetcode and coding it. And if you haven't got the approach, don't worry, I'll explain it again with the code. So first what we have to do, we have to, there should be a base case, right? Suppose if there is only one balloon, so we have to shoot only one arrow. So if the points, that is the 2D array that is given, if it has a size of 1, so you have to shoot one arrow no matter what. We have to shoot one arrow. So return 1. Alright. This will be our base condition. Next, we have to take a answer variable that will be the number of arrows. And what we did at the first, we had to sort the balloons in ascending order. So we'll just sort the balloons. The sort function, I hope every one of you know it. Begin and points dot end. So now our balloons are sorted in ascending order. So what did we see at first? Whatever be the coordinates of the first balloon, we have to, our first variable that we are keeping were the coordinates of the first balloon, right? Were the coordinates of the first balloon, whatever be the coordinates. So we'll keep our variable, suppose int xlen, we keep our variable that as the start coordinate of the first balloon, right? Start coordinate of the first balloon. And ylen, that is the ending coordinate, we take as the ending coordinate of the first balloon, right? Now what you have to do, you have to start from the second balloon, right? We have to start from the second balloon and we will check if it has any common points with our variables, right? With our variables. So if let's give the condition of it doesn't have any common points, that condition first. So if points of I, that is the ith balloon, and the 0, it is the start, greater than y of len. Okay, so let's understand this here. This was this condition. We burst all the 4 balloons with one single arrow, right? So what was the last coordinate that came was 4 and 4. Remember, 4 and 4 came. So if the starting of the ith balloon is greater, that is 7 is greater than the ending of the variables that we are keeping, common variables, then we have to change the arrow. We have to change the arrow because there is a space in between, right? That's what we are doing here. We'll update the arrow variable because we are changing the arrow. And also what we're doing, we'll update the xlen to points of I of 0 and ylen to points of I of 1, right? This is what we did. Remember, we changed this 4 and 4 to 7 and 10 that time. Remember, that's what we are doing in the code, right? Now that condition comes if it's common. This was of not common. If it was not common, the balloon doesn't have any common coordinate. And now if it has any common coordinate, so if it has any common coordinate, what we are doing, we are keeping our algorithm that the xlen will be updated to the maximum of xlen and the new points, that is the starting point I of 0, right? And similarly ylen will be the minimum, right? Ylen will be the minimum. Let's go back to our okay. So now let's go back to our one note. See, first it was 1 and 6, right? Then the next balloon came 2 and 4. So we did the maximum of these two, right? because here if we shoot the arrow, we won't be bursting the 2. So 2 came, and here from here the minimum, so that if we do this, then we'll get the common of both the balloons. So minimum was 4, we did 4 at first. This is what we are doing here. All right, and at last we'll just return answer plus 1. Now why we are doing answer plus 1? Because see, at last this was left, right? Well, we considered, we shot one arrow with all the 4 balloons, we shot one arrow with 4 balloons, and we shot another arrow with these 2 balloons, but this was left, right? This was left. So we have to increase our answer. We have to increase our answer by 1. So this is the code. Let's run the code and see if it gives the right answer. Yeah, right answer. So let's submit our code. Yeah, see, we have a very fast solution of 86.59%. I was trying first, see the runtime 800, now it has come down to 392. Don't trust Leetcode runtime, please. Same code gives different runtimes, and 63.52%. So this is an optimized solution, and I hope you have got the intuition and the approach to solve this problem. If you have got it, please like, give a comment, and also please subscribe to the channel. I'll try to bring everyday daily set of Leetcode explanations. Thank you. This is Sai Ghosh signing off.